Guys, let's have a look at the analysis for the thermistor core practical, which is a bit more complicated because we need to use logarithms. So let's have a little look at this. Right, so yeah, I did two videos for this because the first one, I used my laptop and I used some video broadcast software, which crashed halfway through. I think it stopped at 45 degrees C. In the second video, we get the full range. I think it drops to about 30 degrees C. So that's going to be much better for us to analyze. Because don't forget, the main objective of this core prac is to fully calibrate a thermistor. So we want as much data over as big a range as possible. So anyway, this is the video I wanted you to analyze in the end. Right now, I think you might have plotted already a graph of resistance against temperature, and we get it's a negative correlation, but it's a curve, isn't it? Okay. So what's the meaning of the curve? What's the actual function? Right. The actual relationship, the actual function, the actual relationship between resistance and temperature is this one. Okay. It is exponential in nature. That's what the E is there. All right. But it's quite a complicated one because these are the two variables. The independent variable temperature is there. The dependent variable resistance of the thermistor is there. Now your R1 and B are constants. Now E, I'll come to that in a minute. That's called the natural number, which is a constant. It's a mathematical constant, which is 2.718 to the nearest third decimal place. So anyway, that is our relationship, which is why we get a curve. So it's why it's definitely pretty far from being a linear relationship. But we need to get it into a linear relationship. So that's really what we're going to be doing today is looking at this equation and turning it into the form y equals mx plus c. Okay, and then we can plot a graph and do our straight line of best fit. So anyway, how on earth do we get something like that into the form y equals mx plus c? Well, you've done this skill to some extent throughout year 12, where you've looked at equations and you've got them into the form y equals mx plus c, but you've never done that where a power is involved. If a power is involved, you need to use logarithms. That's the bottom line. Okay, so just one extra thing here. The temperature in this relationship, the temperature is absolute temperature, which is in kelvins. So we'll come back to that. We'll come back and figure out how we go from Celsius to kelvins. But anyway, let's have a little look at what logarithms are. Right, I believe you've all just done this in maths. So thanks for your emails, your replies to my email today. Those that did, saying yes, we just covered them. If you haven't, if you don't do any of the maths, then I think you maybe need to do just a little bit of research. But in physics, it's literally just a case of putting a number into a calculator and pressing one of the two log buttons. Okay, so what are logarithms? Let's have a little think about what logarithms are. Okay, basically, to put it simply, a logarithm is a power. It's as simple as that, really. Okay, it's a power. Let me explain. Right, you could write, or we could write, log. Now, a logarithm always has a base, and that's it. That's subscript. So log. Let's go with base 10. Let's keep it simple. Right, the logarithm to base 10 of let's say 100 is 2. Okay, so that's saying the logarithm of 100 to base 10 is the number 2, because the logarithm, this thing here, is, like I said, is a power. If we take the base, to get it to this number, we have to raise the base by a power of 2, because, wait for it, 10 squared is 100, isn't it? Okay. But what about another one? let's keep it log 10. Log base 10 of 1,000 is, any guesses? Well done. Is 3, because 10 cubed is 1,000. So it's as simple as that. A logarithm is a power. So if we take our base and we want to get it up to that number, we have to raise the base by a power of what the number or what the logarithm is. So a logarithm is a power. Okay. One last one. This is an important one because this is incorporated in one of the in as one of the log rules. What about log base 10 of 10? What if the base and the number we're logging are the same? Well, that is always 1. Okay? And that works for any base. If we have log to base 2 of 2, the answer is 1. And all because, okay, all because, obviously, 10 to the power of 1 is 10. Make sense? Easy peasy? Right. The only 2 logs that you need are log 10 and log e. Okay, so log to base 10 and log to base e. Now, log to base 10 is written on the calculator as just log. So that's actually shorthand for log to base 10. If you ever see written just log with no base, that will usually mean log to base 10. Okay, so that's this one here. Now, the other log that you'll only ever use in physics is log to base e, and that is written like this, ln. Okay, n stands for the natural number, because this thing here, the e, is called the natural number. So ln just means log to the base e, where e, it's a constant, it's a mathematical constant. Don't ask me where it comes from, I can't remember, but it's roughly, okay, 2.718 to 4 significant figures. But your calculator knows that. You'll never have to key that into your calculator. So they are the only 2 logs. They're the only 2 bases that you will use in physics, which is convenient. Okay, in maths you'll be using loads of them. All right. Now, the logarithm rules. This is what we need in physics. This is what we need to tackle this equation here. Okay. Right. These are the 3 you use in physics. Okay, there are more in maths, obviously, but these are the 3. The first one, they call it the product rule. That's what if you have the logarithm. Now it says to base 8. These 3 rules and all the log rules work for all the bases. So this base could be any number, which is convenient because we only want log to base 10 or log to base e. Okay, so the base is unimportant, but it has to stay the same. Right, the logarithm of a product is equal to the sum of the individual logarithms. So log xy is equal to log x plus log y. Make sense? The quotient rule, similarly, the logarithm of x over y is log x minus log y. The second rule that you use in physics. And the third one is called the power rule. Now, log of x to a power, okay, is you basically take the power down to the front. It's as simple as that. You literally just take the power and stick it at the front. Okay? So log of any base of x to the power of p is p log x. Make sense? That's called the power rule. Right, there you have it. Your three power rules. So your three logarithmic rules. Now this can be where x, y, and p are constants or variables of your choosing. Okay, these rules will be for any values of x, y, and p, and they work for any value of base. So there you go. There's your logarithms and your logarithm rules. How are we going to use them to tackle this then? Okay, right. This is r equals r naught. This is a constant. Multiply, the dot means multiply by e to the power of b over t. Okay, now we can get that into y equals mx plus c by logging both sides. Now, which base to use? Is it log 10 or is it log e? Well, because we have e in the actual equation, it would make perfect sense, would it not, to go with ln or log to base e. So that's what we're going to do. That's exactly what we're going to do. Right. I'm going to go through it on this video. I want you, this is, I'm going to share this Google Doc with you. This is yours because there's a table of results, but I want you to write out this rearrangement. I want you to practice rearranging it. So what was the equation again? It was r equals r naught e. Now it was b, a constant, over t, absolute temperature. Right, how on earth do we get that into y? Is it y equals mx plus c? Right, we're going to use natural logarithms. So you take the natural logarithm of both sides. Don't forget, in maths, in all equations, if you do one thing to the other side of an equation, you just do it to the other side, and the equation is still valid. So natural log of r is natural log r naught e to the b over t. Okay. Now, first thing, which rule are we going to use first? It would make sense to split up this and this, wouldn't it? So we're going to use the product rule. Don't forget the product rule is log xy equals log x plus log y. Let's try that one. Right, so natural log r is natural log r naught plus natural log e to the b over t. So this b over t, this is the power. This is the power that e has been raised to. Okay. Just gonna remove the parenthesis here because that was bothering me a little bit. Yeah, so this power here, b over t is the power. Right, next step. What's next? Right, what about we need to do something with this, don't we? Okay, so that's an open bracket sign. Right, so we've got natural log r equals natural log r naught plus, now remember what you can do with the power? You can take the power to the front, can't you? Let's do that. So that equals, so plus b over t, because that whole thing was the power, multiplied by natural log e. Now don't forget, ln e is log to base e of e. Now what did I say that was always equal to? The log of a base of the same number is always 1. So ln e is 1. Almost there. Okay. Almost there. Right, so let's finish this off. Natural log R is natural log R naught plus B over T. The ln disappears. And finally, I'm going to go with natural log R equals B over T plus natural log R naught. And then finally, I'm going to go with, I'm going to do just this thing here. I'm going to go with natural log R equals B multiplied by 1 over T plus natural log R naught. Now, why have I done that? Any guesses? Well, the reason obviously is to make it blindingly obvious that it's now in the form y equals mx plus c. Remember, if R naught was a constant, then natural log R naught is the constant. That is a constant. B is still a constant. So we have only one choice, but to plot values of natural log R on the y-axis. We're going to plot 1 over t on the x-axis, meaning that the gradient is going to be b, and the y-intercept is going to be log R naught. So there you have it. We've now rearranged that equation into the form y equals mx plus c. It only means now that the last bit is plotting the graph. So what we're going to plot? Okay. We have got natural log R on the y-axis. We've got values of 1 over t on the x-axis. Now that should, in theory, be a straight line. Okay, and the gradient is going to be b. The gradient is going to be b. Okay. Right. We need a table then, don't we? We've got quite a lot of manipulation of data to do there. So in this document, I've prepared this table for you. From the video, what have we got? From the video, you had values of temperature in degrees Celsius. But like I said earlier, we need to convert those into kelvins, don't we? We then need to take the reciprocal of those temperatures in Kelvin to give us our values of 1 over t, which are going to be plotted on the x-axis. From the video, our value of resistance is in kiloohms. We need to get those into resistance in ohms, and then we need to do natural log of resistance in ohms. Okay, so just to quickly recap how you use your calculator to get these values. I know you can do that, but how do you use your calculator for this? Well, it's quite simple. Let's take a value of resistance. Let's go for this one here, 0.57 kiloohms. Okay, so if that's 0.57 kiloohms, what have we got? 0.57. How many ohms is that? 570, isn't it? What do? You go to your calculator and you key in, what do we key in? You key in 570 into your calculator and you press that button. That will give you the natural log of 570. You literally press that button and the number it gives you is the natural log of 570. I'll just do that now. 570 natural log 6.4345 3466 0.346. There you have it. You have your results. You have a graph. You know how to do that. eagerly looking forward to your values of R0 and the gradient B, and whether you get any anomalies. I think I've covered everything. Right, there you have it. This is what we do in year 13. This is how we analyze data in year 13. Okay, this is the big practical skill in year 13 in the analysis parts of our core practicals. Right, have fun, guys. See you later.